ready? Aren't you going to wash your hands?
But they're clean.
Why should Lucy wash her hands? They look clean enough. But what if you look closer? 10 times. 100 times. 1,000 times. 10,000 times. And 100,000 times. What is it on her hands? No wonder she looks surprised. Whatever it was, she couldn't see it with the naked eye. Of course, the eye can't see things as small as that. If you look too closely, everything becomes a blur. The eye needs help. One clue might be in nature itself. Have you ever noticed how drops of water seem to make things look bigger? People must have known this for thousands of years. But what is it about a drop of water that magnifies these letters? Is it the water or the shape of the drop? We can make the same shape out of a different material that's as transparent as water. It's molten glass, shaped like a drop, and left to cool. But will it magnify? It certainly works, especially in the middle. So it seems to be due to the shape. But a scientist always checks. Let's see what happens when we use a flat-sided piece of glass. There's no magnification now. The writing is distorted, but no bigger. It doesn't work. But what if the surfaces are curved? To make them curved, the disc has to be ground, using a method that's centuries old. Once it's ground, the glass has to be polished. And look at this. If you get the shape right, the glass will magnify clearly. It's called a lens. However, scientists wanted to look closer. They tried by moving the lens, but found the image became blurred. It was becoming a problem to solve.
This is only to start with.
But they did find a very important use for lenses. Glasses, which have been around for hundreds of years.
And we'll cover up at a time. Can you see the letters better with that lens?
No, it's probably that.
Better.
It was probably in an optician's that a lucky discovery was made over 300 years ago.
What do you think, Lucy?
As the story goes, it was 2 young apprentices who made the discovery. They knew that one lens could magnify. But what if they looked first through one lens and then through another?
Have a look at this.
To their surprise, the second lens helped to magnify the image even more. To the people of the day, that was a very exciting discovery. They mounted the lenses in a wooden tube. It was called a compound microscope because of the effect of one lens on another. They could now take a much closer look at the world around them, and it was fascinating. Views like this encouraged the great scientist of the time, Robert Hooke, to make a bigger and better microscope. He still used 2 lenses, and he also found a way of getting more light on the things he wanted to study. Hooke spent weeks on end observing things and drew what he saw in great detail. This is his drawing of a flea. Never before had one been observed so closely. Believe it or not, this is also a microscope, but not a compound one. Instead of 2 lenses, there's only one, a tiny fat lens shaped like a minute marble. It was the fatness of the lens that made this little microscope so successful. but it was very difficult to use. It was made by Anthony van Leeuwenhoek, a Dutchman, and it was really only he who had enough patience to get any useful results. So it was the compound microscope that survived. It was easier to use, and they were able to study the things they wanted to see for hours. But there was a problem. The closer they got, the less clear things became. Look at the outline of the flea. If you take an even closer look, the blurring gets worse, and rainbow colours start appearing, making it impossible to see more details. For 100 years they were stuck, until an optician called John Dolland made an important discovery. He realized that if he put two different shaped lenses together, each one made from a different kind of glass, he could produce a new type of lens, which he called a doublet. Using doublets instead of ordinary lenses, the compound microscope gave a clear image once again. Now it was possible to see even closer. Suddenly, scientists realized the importance of the compound microscope for studying the micro world. They had found ways of mounting specimens so that they could shine light through them instead of onto them. The results were fantastic. They saw bacteria for the first time and began to discover more about the links between bacteria and disease. But they found there was still a limit to how much these microscopes would magnify. Today, we can look very much closer at things. This may not look like a microscope, but that's just what it is. Here, instead of shining light through the things you want to see, you use a beam of electrons. It's called an electron microscope. Now you can see things even smaller than bacteria, called viruses. This is the virus that causes whooping cough. And these give you chickenpox. They've been magnified 150,000 times. This is the virus that gives you severe tummy ache and sickness. And the one most of us are inoculated against, the polio virus. Ernst Ruska is the scientist who made it all possible. It was he who had the brainwave of using electrons in microscopes instead of light. That was 40 years ago. Today, we've found other ways of using electrons to give us an even better view of the microworld. In 3 dimensions. This is the head of a match, 70 times larger than life. A fly's head, 130 times larger. And at 430, the hairs on the back of a potato leaf. At 1,000, a razor cutting hair. At 2,300, a broken hair. And a grain of pollen at 2,800. And remember this? It's a virus that attacks bacteria magnified 100,000 times. Remember where it was? Perhaps Lucy should wash her hands after all. Solving the problem of seeing that virus took hundreds of years of scientific effort.